So, today we will demonstrate another experiment using the spectrometer and prism. So, this experiment is draw angle of incidence versus angle of deviation, not angle of minimum deviation. This curve of a prism for a particular wavelength of light. So, for a particular light means for a particular wavelength, if it falls on the prism, then we will change the incident angle of the light on the prism and measure the deviation. Then we will plot deviation as a function of incident angle and get a curve. Okay. So, basically we will get a curve like this, we will get a curve like this. Okay. So, different deviation at different incident angle, we will plot and get a curve like this. Okay. And what is the aim of this experiment? Basically, from this experiment we can find out the angle of minimum deviation. Then we can calculate the angle of prism. Okay. Also, we can determine the refractive index of the material of the prism. Okay. So, first we have to do the experiment for getting deviation at different incident angle, and then these different parameters we will find out from this curve, right. So, obviously you can see this deviation is minimum at this point. So, this corresponding angle is here theta I 0 I have written. So, this the this for this incident angle. So, this is the minimum deviation. Now, if you increase the angle, so deviation is increased. If you decrease the angle, also deviation increase. Okay. Now, so now you know the minimum deviation for this prism for particular wavelength. Okay. And basically the really using this relation that theta I 0 at which you are getting the minimum deviation, that is equal to delta m means minimum deviation plus angle of prism divided by 2. Okay. So, you know the theta I 0 and you know the delta m. So, you can find out the angle of prism. So, if you know the angle of prism and the minimum deviation, so this refractive index you can calculate from using this formula. So, already we have done the experiment how to measure the angle of prism, how to measure the minimum deviation, right. So, this angle of prism basically without using this method, one can separately find out the angle of prism also and minimum deviation from this curve and calculate the refractive index of the material. Okay. So, let us do the experiment let us do the experiment. So, first reading for direct rays. Okay. Reading for direct rays means this. So, this is the collimator, this is the telescope. So, this setup is already it is in the condition of doing experiment, means using the Schuster's method. So, we set it for parallel rays, okay, labeling, and then for parallel rays whatever requirement before starting any experiment using the prism. So, that is done, and how to do that we have showed you, explained you. Okay. So, we will not repeat it. So, now reading for direct rays, right, means this is the source and this the slit is here. So, slit source is here. So, from collimator parallel rays are coming, okay, and directly falling on the telescope. Now, I will set I will set the crosshair at the direct. Yes. So, this is the direct position of the telescope, where the slit image coincide with the crosshair. So, I keep crosshair basically this way. Okay. So, it's really cross, not in plus position, crosshair. So, this and the spectral lines is like this, spectral lines is like this. Okay. So, now what you have to do? You have to, so we have two verniers, vernier 1 and vernier 2. Now, I will take reading from vernier 1. So, main scale reading, how to take reading I explained, then vernier scale reading, right, and then total, that we are telling R0 for vernier 1. Similarly, I will take reading from vernier 2. So, right now this reading I can show you or tell you. So, I have to use, I think one has to be careful. Yeah, is disturbed. So, because my body touch the, so actually one should clamp it. One should clamp it. One should clamp it, and then I will use the this fine crosshair, but somehow it's not working. It has some, okay, I understand. So, I have to disturb. Yes. Now I set at this position, then I clamped the uh, telescope. I cannot rotate. Okay. So, only I can rotate using the this fine screw. still it's not working. Okay, I think I have to some disturbance. Okay. Yes, now it's working. So, first we have to take reading for direct rays, right? So, let us see the spectrometers. So, this spectrometer is set for the parallel rays. Okay. So, how to get the parallel rays, how to level it, so that we have discussed. So, that we have already made, we will not repeat that one. So, now first for direct reading we have to set this, we have to bring this, we have to bring this telescope parallel to the collimator, parallel to the collimator. Yes. Yes. So, approximately I have set this crosswire to the spectral lines. So, now I will clamp this telescope. I cannot rotate it. Okay. Only using the fine screw I can rotate it. Okay. Using the fine screw only I can rotate it. Okay. So, reading will change also. So, now using this fine screw I will set the spectral lines exactly at the cross point of the crosswire. Yes, I have set it. Okay. Now we have to take reading of the vernier 1 and vernier 2 for this position. So, I can basically use light for see this reading, and also I will use the this one. So, reading I can see this is approximately 350 350 and then 0, yeah, it's 50, 49, 48, around 347. That's the 347, and one has to find out the vernier. So, I am not going to do that. And also other one we have to take reading. So, it's around, I can see 0 is of vernier is meeting, it's the around 170. So, that is around 350 and this is around 170, of course. So, it will be close to that. Now, we can see the reading difference between these two, each is 180. So, 350 and 170. It is not exactly 350, it is a 347 and then some vernier constant one have to find out, and this is 170, I think around 173 or like this. Okay. So, So after taking reading, just cross check that it should be approximately 180 difference. Okay, take the vernier reading carefully. So using the this magnifying glass, one has to see carefully. So one should need very good eyes. Okay, so find out. I am not going to do that. So write the reading. Write the reading, vernier main scale reading for vernier 1, and then vernier scale reading. Okay, and vernier constant is 22nd. The same spectrometer we are using earlier. We have shown that it's a 22nd. Okay, so this total reading are 0, that is m plus v. Okay, so now for vernier 2 also write down. Now just we take generally observation 1, 2, 3. Okay, this means, so again you just adjust, and try to make more accurate. Okay, and again take reading. So this way 3 times generally we take reading. So there's to minimize the experimental error, we take more observation. Okay, so whatever the reading one should note down. Okay, so this way, this for direct reading of the telescope, that means this telescope is parallel to the collimator. Direct light from the collimator is falling on the telescope, and we are seeing the image, and what is the position of this of the telescope at direct rays, so that we find out in this method. So one has to calculate the mean R0 for vernier 1 and mean R0 for vernier 2. Okay. Now next what we have to do? Next we will take data. For angle of incidence and deviation. Okay. Remember, this is not minimum deviation, it is the deviation. Okay. So the table here I have written number of observation. Okay. Then verniers numbers, then reading for the refracted rays. Again this main scale reading, vernier scale reading, total reading. We will take observation. Okay, 1, 2, 3 observation, or at least 2 observation you should take. Then we will find out mean, that is we have given R1 for refracted rays, R1. So then next reading for the reflected rays. Okay, reflected rays. So here also main scale reading, vernier scale reading, total, this R2, then mean R2. So for basically this each one basically for different angle of incident angle that we can. So this is for this each observation is for each incident angle. Okay, for observation 1, this for a particular incident angle. Okay, for that angle we will set the telescope at the refracted rays, take the reading for vernier 1 and vernier 2. We will set the telescope at the reflected rays, take the reading for vernier 1 and vernier 2. Okay. So this deviation, then deviation is basically that refracted rays R1, position of the refracted ray R1 minus the direct R0 is the position of the direct rays. Okay. So, from direct rays, whatever the refracted rays, okay, emergent rays, so that angle is basically deviation, and incident angle, so that is theta I, equal to 180 minus this R2 means refracted rays, position of the refracted rays minus the position of the direct rays. Okay. So, that means this from direct rays, what is the angle of the refracted rays? So, that is the deviation. From direct rays, what is the angle of the reflected rays? So, that is R2 minus R0. So, from 180, from here you can see from 180 minus of this angle. So, basically here you can see, so these the direct rays, this is the direct rays. Okay. So, that R0 reading is R0, okay, that we have taken. Now, this is the refracted rays. Okay. So, now this reading we are taking, that is R1. So, R1 minus R0, that is delta, and reading of the reflected rays, that is R2. So, this is the reflected rays, okay, R2. So, now direct one R0, okay. So, R2 minus R0 is basically this angle, right. So, now this is the normal. So, theta I is the incident angle. So, reflected angle also theta I. So, this angle is 2 theta I, and this angle is, here I have written phi, basically R2 minus R0. Okay. So, this angle along the straight line, this is total angle is 180. So, 180 minus this phi means R2 minus R0, that will be equal to 2 theta I. So, theta I will be 180 minus this R2 minus R0 divided by 2. Okay. So, that is what here I have written. That is what here we have written, theta I equal to 180 minus R2 minus R0 divided by 2. Okay. So, so basically we have to take reading for refracted rays, we have to take reading for reflected rays. Okay. Then we can get the deviation for a particular for the incident angle. Okay. Then we will find out the mean deviation and mean theta I. Okay. So, that you will get for each, basically for each, I think I should just, so for a particular angle, this is the angle. Okay. This is the angle, and what is the deviation? So, we will get from this is the mean deviation and this is the mean theta I, and then this then I will change the rotate the prism slightly. So, I will get this for second position of the prism, means for next incident angle of the prism. Okay. I will take second observation. So, again I have to take for vernier 1 and vernier 2 reading for reflected rays and refracted rays. Okay. So, that way we will continue these 5, 6, 7 observation for different position of the prism, means for different incident angle. Okay. So I will stop here. Thank you.